I wanted to make an update video on my 8700K build. Made some changes to the computer. I've also had time to play with overclocks and overclock it to where I can find it that the noise isn't that bad. But first, let's go over some of the changes. So change number one is I added another fan to the cooler. And change number two is I added a sound card, a Creative Labs Z, I believe. The reason I like using this card, and this card was from my previous computer, is because it has Dolby Digital Live, and I like piping the sound to my stereo receiver. So when I'm playing games, it's in surround sound. I've also moved the front audio jack to it. Unfortunately, there's still somewhat of static going through the line, but it's not as bad as the onboard audio. But the onboard audio basically connected right next to the power supply down there. So I'm not sure if I was getting noise just from the power supply itself, electromagnetic noise going through the line. So I did move it over. It's still staticky when I put the headphone in, but I guess that is what it is. So what I've done is I bought an extension line that goes out to the back, and it goes to this little port that I 3D printed. So that helped quite a bit. Actually, it works perfect. There's no noise coming out of that whatsoever. One other thing, when I installed the Creative Labs card, I wasn't able to do a 5.0 stable overclock at 1.310. Not really sure if the card is just taking a little bit more power. Obviously, there's some power draw, some current drawn from that card, but I've had to up the voltage to 3.250 in order to overclock it to 5.0. Not really quite sure what's up with that, or maybe I degraded the performance of the CPU a little by playing around with the different type of overclocks. I did accidentally set an offset. I put it in offset mode, and I set up SVID support. And when I booted into Windows, I saw right away it was giving me volts of 1.6. So I shut it down right away and put it back to a lower voltage. So yeah, be careful with that SVID support. Not really sure how that works, but yeah, it could have possibly fried my CPU there. Glad it didn't. Like I said, I'm still able to get to 5.0, but it's at a higher voltage right now to get it stable anyways. All right, so the next part of the video, what I wanted to do is put the PC in different overclocks from default to 5.0 so you guys can see the noise difference using Resolve. Basically, when I was doing the 5.0 overclock, it was just too loud for the fans that are in there. Everything ramped up pretty much to 100%. So that got really loud. So I guess I have a couple options I could do. Obviously, I'm still thinking about delidding it, and I actually got my delid tool ready. I have to model out an alignment jig, so when I glue back the IHS, it will be perfect. Haven't done that yet, but by the way, I downloaded this from Thingiverse. It's if you look up delidding tool, it's the first option there, but I'll put a link in the description. If I do happen to delete it, I haven't been brave enough to do it yet. I'll put a video up on that. I still have to buy the thermal compound for that as well. So yeah, so let's get into the BIOS. Let's change the overclock to different settings that I have, and let's listen to the noise as we render out just a small scene, little short clip that has stabilization and a LUTs applied to it in Resolve, so you guys can hopefully hear the difference. Right now it's perfectly quiet. The only thing that's making noise is there's a hard drive that's right behind there that is really loud. That's the only thing I hear right now. But other than that, I'm very happy with the build. And let's go over the noise. So let's start out with changing everything back to default. So we're starting from ground up. So I'm going to go into exit, and I believe is load optimized defaults. All right. So let's go back to extreme tweaker, and let's go ahead and actually let's turn off multi-core enhancement. So basically everything is just on auto. So I should be as factory as we can get it. So let's exit, save changes, and restart. All right, let me just set this up so we can see everything. I take out voltages because, well, voltages in this one would actually help. It seems to be reading okay. Well, not really. So let's keep temperature, fan RPMs. So let's take out voltage. We have temperature and percent. Let's take out power so we can also see the core speeds. So this is the, well, let's open up Resolve. Okay, so this is the stock setting without XMP nor multi-core enhancement. We have a couple different tools available open. So we have the AI suite so we can monitor the voltage here and the temperature, but we also have CPU ID. I hope this turns out okay on the video. Actually, let me turn the monitor a little bit this way, so towards the camera, so I can read it a little bit better. So I have the camera on a tripod, so all these tests will be ran in the same position. That way there can't be a sound difference between the camera and the computer. So what I have here is just a test clip that I put a LUT on it, and I did some color correction, and I stabilized it. And to use all the cores and the CPUs, I want to go ahead and start a render. So let's see how long that takes, and let's see how, one of the things to pay attention is the speed of the RPMs and the sound that you're going to hear from the computer. So as you can see, the RPMs are up here, sorry. Looks like we're bouncing around 200 now, but let's go ahead and clear the mins and max. And let's go ahead and give it a render. All right, took 48 seconds. The voltage did bounce about a little bit. Now, I don't think I saw it go past 3, but I have seen in stock settings the V-core voltage, at least on this utility, actually go to 1.3 and higher. I don't know if it's a BIOS issue or not, but yeah, I've definitely seen it do that. So let's go ahead, let's go back into the BIOS, and let's do XMP with multi-core enhancement on, and let's see what that does. Okay, we're going to go back to the BIOS and turn on multi-core enhancement, and let's turn on the XMP profile. It does give me a warning that I need a pretty good cooler. I'm going to save changes and restart. Okay, so here we are back in Resolve. Have the same temperatures and fan speeds available, the gigahertz and the megahertz here. So we can see, I'm actually going to wait a second until this settles out. There we go. Maybe something on startup going up, but all right, there we go. So let's do the render. Now pay attention to the voltage. I think I've also seen this come up to 1.3. So I'm going to go ahead and click start, and you guys can listen for the fan. Okay. Let's go ahead and do the next one. Okay, so the next overclock, I'm going to use the overclocking profile. And I'm going to do profile 6, which is 4.7. And the reason I want to do that is because, remember, the multi-core enhancement basically pushes all cores, I want to believe, to like 4.4 on all cores while all of them are there. But I want to show you that if all you wanted to do is get the CPU and a motherboard and just have XMP and multi-core enhancement, that you can actually do the same thing by just setting the voltage manually and actually get a cooler system, and also lower wattage as well from what I've seen. So I'm going to load profile 6. I'm going to go to and show you what that has. So that has XMP. It has multi-core enhancement disabled, SVID behavior on auto, but I believe I have, yeah, the support disabled. I also have the power, low line calibration to 5. And the internal management, I've also changed the long duration power limit and short duration power limit to max. And we have a manual, we have the voltage on manual mode, and the voltage override to 1.2. So we're going to exit and save changes. Okay, so here we're at 4.7 overclock on all cores. And once again, keep an eye on the voltage, which I've manually set, and the fan speeds. Okay, let's do the next one. Okay, let's go back to the overclocking profiles. And this time I'm going to do the very last one here, which is basically per core overclock. This is the one I've been doing for my daily driver for overclock anyways. So let's go to profile 8 and I'll show you what that is. Alright, so we still have XMP on, disabled multi-core, and what I have it is per core. I have, if it's running 2 cores, it'll boost up to 5 gigahertz. If it using 3 cores, 4 cores, 5 cores, or 6 core, it'll just bump up to 4.8. And I have an AVX offset of 3 on this one as well. Although I don't think we'll see that happen. I think it's going to be at 4.8 for when it does the rendering. And then we have pretty much everything else is the same, except I have a volt of 1.250. And like I said, I believe the power management's maxed out on the power limits. And the low line calibration is 5. So let's save changes and restart. And I just noticed something as the system's booting up. On that profile, it actually has a fan profile that I will kick it to 100 at 65 degrees, where the other profiles that we tested so far is at 70 degrees, so it'll kick it in at 100%. Okay, so just as a reminder, this is 2 cores at 50, and then the rest, if it's the rest of the cores active, it'll be at 48. Okay, next let's do the all core overclock at 5.0. All right, we're back in the BIOS and let's load the 5.0 profile. Let's take a look at that. Okay, so once again we have XMP on, multi-core enhancement disabled, AVX offset of 3, SVID support disabled. We do have load line calibration, oops, wrong one, over here, of 6. And power management, I have both limits at max. The voltage is at 1.325. Another thing I have changed is to keep the temperatures down at 5.0 is for the CPU. I'm going to change it to turbo just because I feel safer when I'm overclocking at this speed. Oops, I don't think I actually changed it. Do that again. Okay. Yep, no, I did. Okay, so we are going to exit, save changes, and restart. Okay, so this is all cores at 5 gigahertz with the AVX offset at 3. Pay attention to the temperatures now and the RPMs. I am getting a little higher temperatures now that I'm at 3.250. And hopefully you can hear the fans ramp up. Okay, that wraps it up. Want to get your thoughts on what I should do next. I'm probably going to delid it before I think about getting a AIO cooler. Like I said, the delidding tool's ready to go. I just got to model out a alignment jig to be able to glue the heat spreader back into the CPU. And you know, if I do go water cooling, you know, I was thinking of a 360 rad, but I'm not really sure what to get. I'm a little worried about pump noise because I did have a older Cooler Master cheap AIO cooler, 120 AIO cooler, and the pump noise really bugged me to the point where I switched it out right away and bought a Noctua cooler, and it performed better than that one anyways. So I've been worried about AIO coolers in general making too much noise. But if we're going to do extreme overclocks like this, you know, I think it's going to be quieter on when it's at load versus at idle, where I think the cooler would be quieter at idle than an AIO pump if the pump is noisy. So if you guys can recommend what pumps or what AIOs aren't noisy, or if maybe I should just do custom loop of what pump is the quietest pump out there, maybe I'll give that a try. But first I think I'm going to try the delid option and go from there. Let me know what you guys think. You guys have a good one.